Welcome to Electron Chemistry tutorial. I am Vijayalaxmi. Now I am going to teach you reaction mechanism. Before classes we learnt about speed of the reaction, rate of the reaction. And remaining topic in the chapter reaction mechanism. So how to define reaction mechanisms, which terms involved in this reaction mechanisms, all are studied in this topic. Okay. Reaction mechanism. Generally, reactant get converted into products. Clear? If reactants directly convert into products, final products in a single step, such type of reactions are called elementary reactions. Elementary reactions. Okay. Suppose reactant get converted into products through multiple steps. So such type of reactions are called complex reactions. Complex reactions. Okay. So majority of the reactions are complex reactions. Majority of reactions are complex reactions. Okay. Simply what I am trying to say here, elementary reactions, how to define? So reactant get converted into final products in a single step. They are called elementary reactions. Okay. Then complex reactions, nothing but the reactions in which reactant get converted into final products through several steps. So they are called complex reactions. Okay. See here, in complex reactions, the sequential representation of means A gives rise to B, B gives rise to C, C gives rise to D. The sequential representation of different elementary steps is known as reaction mechanism. Reaction mechanism. Okay. Majority of the reaction complex reactions, no? So that's why the sequential representation of different elementary reactions or several steps is simply known as reaction mechanism. Okay. So in the reaction mechanism, each reaction go one by one with different rates. With the different rates means a different speed. So one is slow, one is fast. Suppose for example A gives rise to B, fast reaction. Then B gives rise to C, slow reaction. So again fast. Listen to me carefully. The slow reaction can control the speed of the reaction. So that's why this slow step is also known as rate limiting step. Rate limiting step or rate determining step. Determining step. Okay. So now molecularity of the reaction. Molecularity. It's very important topic. Very easy. See here, molecularity is defined as the number of reacting particles, maybe the reacting particles, ions or atoms or molecules. The number of reacting particles participate in the elementary step or a balanced stoichiometric equation. A balanced stoichiometric equation is simply known as molecularity. Okay. What I am saying here, suppose for example here A plus B gives rise to products. Okay. So A is one molecule, B one molecule. So 1 plus 1 is nothing but 2, that is molecularity of that reaction. Okay. What I am saying simply here, number of atoms or ions or molecules, which molecules? Reacting molecules. They are participate in the elementary step or a balanced stoichiometric equation, or maybe for complex reactions slow step, participate in this slow step. They are called simply molecularity of that reaction. Okay, clear? So simply that molecules are collide to each other to give products. Okay. So number of reacting particles present in a elementary step or slow step or in a balanced stoichiometric equation or collide to each other to give products are called simply molecularity of that reaction. Clear? Don't get confused. Suppose maybe that elementary reaction number of reacting molecules is simply molecularity of that reaction. Maybe that complex reaction number of reacting molecules in a slow step, they are what? Molecularity of that reaction. Okay. So simply each and every elementary step is a balanced equation, balanced stoichiometric equation. Stoichiometric equation. So that's why what I am saying here. So molecularity, so number of atoms present in balanced stoichiometric equation, that is elementary reaction. Okay, so that is simply for complex reaction, that is slow step or rate determining step. Okay, simply that molecules involved in that reaction, they are collide to each other to give products. Okay, so that is simply molecularity of that reaction. So what are characteristics of molecularity? Characteristics. Molecularity is a theoretical concept. Theoretical concept. Okay. So it has only positive whole numbers. Positive whole numbers like means 1, 2, 3. It cannot be more than 3 because of, listen to me carefully, so it can't be more than 3 because of, so more than 3 reacting molecules may not mutual collides with each other to give products. So that's why molecularity more than 3 is very, very less reactions. Okay. See here. Suppose for example, some reaction seems to be molecularity has more than 3. Such type of reactions involves 2 or more steps. Okay. I will show you with one example. 4 moles of HBr, 1 mole of O2 gives rise to 2 moles of H2O plus 2 moles of Br2. So this balanced stoichiometric equation molecularity seems to be how much? 4 plus 1 oxygen, 5. But this is wrong. It involves 2 or 4 steps, 2 or 3 steps for completion of this reaction. So each step has its own molecularity is less than or not greater than 3. Not greater than 3. Clear? I will show you that simple step. Now I will show you mechanism. Step 1. So from 4 moles of HBr, first 2 moles of HBr reacts with oxygen to give 2 moles of HOBr. Okay. Now in second step, remaining 2 moles. So 1 mole of HBr reacts with this 1 mole of HOBr to give OH removed as water molecule Br2. Then remaining HBr in third step reacts with the remaining HOBr to give one more water molecule and Br2. Okay. So these three steps, each step has its own molecularity. Each step has its own molecularity. Here molecularity is 3, 2 plus 1. So here 1 plus 1, 2, 1 plus 1, 2. Clear? So molecularity of some reactions appears to be more than 3 by stoichiometric equation. So that reaction should be involved in the different steps. Each step has its own molecularity, so but not greater than 3. Clear? Simply, next based on its values, molecularity, how many times? Maybe molecularity 1, monomolecular or unimolecular. Types, molecularity is 1, so that is what? Unimolecular reactions. Unimolecular reactions. Okay. So example, so write down any example. PCl5 decomposes to give PCl3 plus Cl2. The molecularity is 2. Bimolecular reaction example, 2HBr decomposes to give H2 plus Br2. Okay. So trimolecular reaction I will write here. So trimolecular reaction, 2 moles of NO reacts with O2 gives rise to 2 moles of NO2. So here 2, here 1. Okay. So 2 plus 1 is equals to 3, trimolecular reaction. Okay. So this is about what? Molecularity of that reaction. Okay. So that's all, friends. Thank you for watching this video. Did you like this video? Please like, share, subscribe my channel to get more videos. Okay.